Hello. Hi. My name's Bruce. This is my channel. Thanks for watching. And if you if you're a first-time visitor, if you like this stuff, if you could please subscribe. The like button, whatever, all that stuff that people tend to say in their videos. Well, I say it too. And uh, this is my channel. I try to make videos that are about some ideas of contemporary economics and public policy and stuff. And sometimes I wind up making a video about electric cars. You can see some of that in some other stuff, other videos, if you enjoy that. But pretty much what you see is what you get. And it's me. So hang on, I'm just going to make an adjustment. There's an adjustment. I have made an adjustment. I don't know if it's good enough. I don't know if my adjustment is good enough. I don't know, really. Anyway, okay. What's the deal for today? If you've been following along, you know that I'm on a bit of a kick about housing. And housing is important. And you also know that I tend to talk a little bit about government and people and businesses. So remember, the role of people, your job, your role in our economy, in our society, is to maximize your happiness. Maximize the pleasure that you and your family and your people that surround you enjoy in the day-to-day life. How do you do that? You do it with shelter, with reasonable, food, shelter, entertainment, an adequate level of time for recreation. You can enjoy taking pleasure in watching your children grow up, taking pleasure in taking pleasure. That's your job. If you're a person, you're alive, and you're in an economy. It doesn't matter where. It's your job if you happen to be in the United States, if you happen to be in France, if you happen to be in Australia, if you happen to be in Argentina, if you happen to be even in Russia, or if you happen to be in China, if you happen to be wherever, it's your job is to maximize your well-being. That's your job. And then the role of businesses is to maximize profit, and the role of government is to maximize the well-being of everyone while balancing competing interests, etc., etc., etc. That is the job of government. And it's an important job. Government's important. We're humans, and we've organized our existence, our lives, our society, our civilization around these ideas. But anyway, now I've been talking about. See, I have my box of crayons. I've been talking about housing, and there's a shortage of housing. Some people say there's a crisis of housing. It's a crisis of housing if you don't happen to have a house. And that's how you know it's a crisis, because you have nowhere to live. And if you almost have nowhere to live, it's a crisis. And if you walk around and you see people really struggling to find a house, to continue to inhabit the dwelling that they exist in, then you know it's a crisis. And how did that manifest itself? Well, in a few different ways. I mean, how did it happen? And one way it happened is, I was talking with someone earlier in another video about there's been a commodification of housing, and people have used housing as a transactional item and viewed it as a kind of as an investment, but not an investment like you're going to buy your house and then you're going to enjoy appreciation of that asset over your lifespan, or generational appreciation of assets. But really, it's kind of like it's a transactional thing. I'm going to buy this house, and then I'm going to sell it and drive the price up. That's and I'm not opposed to pricing. I'm not opposed to prices going up, but this idea is that people need places to live. It's important. Now, if you know me personally, you'll know that I have a certain measure of experience with projects, with houses, and with projects that are not houses. But some of them they're pretty interesting. Maybe I'll talk about them one day. But I to protect the innocent, I want to keep a couple of cards up my sleeve. But anyway, a story come out today that some houses that were constructed in Canada, in the province of Ontario, were cold. So you have basically a housing development, like a subdivision of houses, and the homeowners are discovering that their houses are not warm, okay? That their house is not as comfortable as it really should be. And then in Canada, we have a thing called the CBC, the Canadian Broadcasting Corporation, which is really, it's an institution, right? It's our public voice, it's our public broadcaster, and it fulfills an important role in our society. And if you happen to be in, wait a second, this is not pointed in the right direction. Try to correct this so that hopefully I can get acceptable audio in the videos. If you've been following, I'm not very good at making videos. It's a reality. I'm sorry. It's not really my video making is not my forte. I've even shied away from it for like a long time. I was thinking about doing it. I just didn't think I could do a good enough job. And one day I said, oh, you know what? Let's not let perfect get in the way of existing. Anyway, houses. Okay. So the Canadian Broadcasting Corporation, and it's there's a CBC TV, there's a CBC website, they have radios, and they do like news programming and sports broadcasting. It used to be Hockey Night in Canada was the purview of the CBC, and CBC really was an institution that linked the nation from coast to coast. And if you happen to be in the United States, maybe a similar thing might be the PBS, but kind of not really. It's different from the PBS. It's sort of more of a Canadian version of PBS. And even the CBC has changed quite a lot over, because things evolve. I mean, I'm a different person today than I was 20 years ago. What the heck? There's more of me. But hey, the CBC story and houses that hold. Now, let's talk about that. Okay. So, I'm going to draw a house. House. Okay, this is a house, and from the heating and cooling aspect of the house is it's important. I mean, it's important that your house be sufficiently warm. And decades ago, and there's a guy, Mr. Hollohan, who's a Hollohan guy, is heatinghelp.com. But there's a guy that built a career on public speaking about heating buildings. Mr. Hollohan, I forget his first name, but anyway, and so you can learn a lot about the history of heating houses from this guy. But back in the day, like ages being the the teens, there came a thing called open window ventilation for houses and heating systems. So a house that would be built around, say, between 1905 or let's say 1910 and really onward, but 1910 to 1940, let's just, to make it more simple, they used a thing called open window ventilation. And because there was a concern about the accumulation of germs in the house, and so the idea was you would just have the windows of your house open almost all the time, and your heating system in your house should be adequate to keep your house warm, even with all the windows open. Which, if you think about it in the modern context, is absolute madness. It's crazy. And then these houses that were built in that era, they were poorly insulated. They didn't have any insulation, really. They didn't have any control layers. I'll talk about that in a second. They didn't have a lot of stuff, but what they did was brute forced it. So if you ever get a chance to visit a historical building like a fortress or something that's, say, like 400 years old or 1,000 years old or something, or an example in Canada would be the Fortress of Louisbourg. If you visit the Fortress of Louisbourg and observe how thick the walls are and how strong the pillars are and how enormous everything really is, well, what you're seeing is kind of, in a way, it's an absence of design, because you didn't know how big to make it, so you just made it bigger. You weren't sure how strong to make it, so you just made it stronger. And that idea in our civilization was prevalent for a very long time, until I think in an earlier video I talked about the development of steam engines and heat engines. And because the heat engines and steam engines were developed before they were before there was really any scientific evaluation of how their efficiency or how they worked or whatever. They were created by people that were tinkering in their backyard largely. But anyway, so this idea of building thing, and you weren't not sure how strong it should be, so let's just make it stronger. Makes sense? Went for a long time, but now we're in a different era. It's a different era. So now a house. This is our house. Okay. Over here, I'm going to draw kind of a view of the wall of the house. So this is outside, and I'm going to get a different color. I don't know if the colors matter. Someone can mention in the comments if the colors matter. This is inside. Inside's this color because we're talking about a house in winter in a place that needs heating. So the inside's going to be warmer, the outside's going to be colder. Okay. So then on the outside, you're going to have this. This is a layer. This layer, when you look at the house, could be brick, it could be stucco, it could be clapboard, painted, it could be steel, it could be aluminum, it could be glass, it could be a lot of things, but this is the outside most layer, and we call that a kind of a control layer, because it's a layer that's there to control the threats from aspects of the weather, okay, from driving rain and snow and such, so that it's not going to go through. So that's layer number one. Then another layer, might be a little air gap there. This layer is going to be it's kind of like a semi-permeable membrane, where it's like Gore-Tex. Okay, so what it's going to do is it's going to allow water is not going to go this way, but vapor is going to go this way. And the discussion about water can go a long time. You may have heard me say before that there's a science called psychometry, which is a study of mixtures of air and physical mixtures of air and water. People spend their entire academic careers looking into this. It's very fascinating if you choose to go down that rabbit hole. We're going to skip it. But I'm going to say this. Water, most people know water as being H2O. It's two hydrogens and one oxygen, H2O. But really what happens is the water, the H2O, they all get together. So there's a whole bunch of H2Os and H2O and H2O and H2O, and they get together and they form liquid water, like water droplets. But the droplets could be very, very small, but these are droplets. And the size of the droplets is on a, let's call it kind of like a macro scale. They're big. They're big in the world of small things. They're big. Okay. So this stuff, it's like I said, Gore-Tex for your house. But so the big water, liquid water, is not going to come in. Now the vapor, which is dissociated liquid water. So a water vapor molecule is thousands of times smaller than a liquid water molecule. You want that water vapor to go liberate itself from the house. So so you have this layer is preventing rain. This layer is allowing the vapor to go. It's not allowing liquid water to come in. Then you say, now let's have some other protective layers. This is going to be like heat. Okay, thermal protection layers. Now, heat is a manifestation of energy. Energy in the form of heat can be transmitted in about 4 different ways. Way number one is I don't want to get this too bogged down, but way number one is heat can be conduction, can be convection, this is terrible writing, I don't care. Conduction, convection, radiation, can be radiated, Another way that you can transfer heat is by warming up a bucket of water over here and then carrying that bucket of water over there, and that's transferring heat through mass. So conduction, blah, 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 blah. So now we have the context of our layers. So we're protecting from the driving rain. We're allowing the water vapor to leave. Then we're having some of these thermal protection layers in here, and that's not allowing heat to go this way from hot to cold by the methods of conduction. So this is a poorly conducting material, insulating material. There's a bunch of different materials that you're going to commonly see. You're going to see mineral wool. You're going to see fiberglass wool. You might see versions of expanded polystyrene foam. You're going to see stuff. You can use hay bales, horses for courses, whatever, something that's appropriate for your area and its design. So there's heat up there. Then you might even have some more thermal layers. Then on the inside, then you're going to have we're on the inside here, we're going to have another layer there, and this is call this sheath drywall or plaster or something like that. And then finally you're going to have on the inside you might have paint or wallpaper. Okay, so layers, layers, layers from the inside to the outside. You have layers. Now that's the discussion of the wall of a house, and then of course there's windows, which is a sort of basically it's a version of this, but it's kind of a special category. Okay, but it's kind of the same. Now the house. Okay, if this house were built 100 years ago, then what you do is you have no insulation. It's drafty as anything, like the wind just blows right through it. The windows are single pane, they're terrible. But the house is warm. Why is the house warm? Because you have, let's just say this thing, you have a giant fire. That giant fire, it just overwhelms the heat loss from the house, and it makes the house warm. And then, of course, 100 years ago in the summertime, the house would be very, very hot because there was no air conditioning, no control layers like I talked about, and no capacity to cool the house other than, open some windows, and you're going to get some fresh air. That's at the house. Now I'm talking about this CBC story about these houses that were cold. And maybe I'm taking a little bit too long about it. I don't care. I do care. I do care. Okay, so let's take the house in aggregate. Okay, consider the entire house. Now, and you're going to consider this house, pretend that it's 100 years ago. So pretend that it's 1924. 1924, okay? In 1924, on the coldest night of the year, this single-family detached house located in New England or in Wisconsin or Minnesota or Argentina or wherever, or in Canada, this house is going to emit around 400,000 BTUs. It's British thermal units. And I can convert that to watts, which is a more modern way of doing it. But most heating people talk in terms of BTUs. Okay. Now, so in the coldest night of the year, say it's minus 25 degrees Celsius, which is, what is that in Fahrenheit? That's going to be minus 10, minus 20 or something Fahrenheit. It's cold. And this is how much energy is leaving the house. So all you do, if you want to keep it warm, you just have this fire, you have that be 400,000 or more putting energy into the house, right? Energy. And then all the energy is going out like this, okay? But I know that people that watch these videos are quite sophisticated. And you know that in the modern context, that is craziness. That's not what happens. So the question is, in the modern context, what does happen? Well, this same house that's going to emit 400,000 BTUs, if this house is built in Canada to the direction of the building code, or slightly better, or if you had me doing it, roughly, under my direction, on the coldest night of the year, this house realistically is going to emit The same house, the same space, everything's the same. Okay, everything is the same. The same house is going to go from 400,000. It's going to go to some other number like 25,000. So it's not 400, it's 25. So what is that? It's about 95% less energy is going away than it's coming in. Okay, 95% less energy. Now, when you talk about a house, you talk about the mechanical system of the house. People think of the mechanical system, they tend to think about the ductwork and the heat pump, or the ductwork and the furnace. I don't like to say the word furnace because that's just really, these days, it's just no. If you're building a house and you're putting in furnaces, please don't. There's far better options. But you have the ductwork, you have the source of heat, you have the source of cooling, all that stuff. That's what people traditionally think of as the mechanical system of the house. But really, the mechanical system of the house is the whole enchilada. The mechanical system of the house is the roof, it's the walls, it's the windows, it's the doors, it's the everything. Like a modern house is going to have this, say, down here. Okay, this is the basement. So you're going to put about 4 inches of foam or insulating material underneath the concrete slab. The concrete slab is going to be insulated on all sides. There's going to be air sealing here, air sealing there. Then there's going to be some controlled air exchanges so you can have fresh air inside the house. Like, you don't want to breathe stale air. So we can have fresh air that's going to be controlled. So we're going to use a heat recovery ventilation systems that we're going to recover the energy that we've created in the house before we throw that air away. We're going to exhaust stale air. We're going to bring in fresh air. We're going to do a whole bunch of really great things. But this is the house, and we get to this number like this. And remember, I'm saying that, trying to make the point that the mechanical system of the house is the house, the whole house. It all matters. Even consideration of the sun, of the shade, of everything is important. Everything is important. Okay, so now the CBC story, someone built a bunch of houses in Canada, and then the homeowners said these houses are cold. Now, and then the conclusion was that the furnaces aren't big enough. Now, the fact they had a furnaces at all, that's a red flag to me. But the point here is that everything is important. Everything is important. And during the construction of these houses, I assure the homeowners that there was more problems, because the furnace that was mentioned was the size of it was like 40,000 BTUs, and in the mild year that we've been having, in the mild years that we have been having, if those houses are constructed with attention to detail. Now, attention to detail is important because everything matters. I'm repeating myself. That's okay. It's a point worth repeating because everything matters. Okay, these control layers, quite often the homeowners or the builders, the part that they see is the paint on the inside of the house and the paint or whatever it is on the outside of the house. But every single layer matters. And I have personally witnessed in this immediate area surrounding me where people were building. I watch new houses. I watch new houses being built all the time. I do this frequently. I visit construction sites. I visit subdivision developments. I visit large construction projects. I see this all the time. And if you choose one of these control layers, say like one of the outermost layers might be expanded styrofoam. It's pink, styrofoam. And you put that on the outside of the house. It has to be installed perfectly in a contiguous manner. All the joints must be sealed. There can be no air gaps. There cannot be any air gaps. And what happens, what I see happening is that this is the styrofoam. is it gets installed like this, and then there's a piece like there, and then there's a big gap like there. And then if you look at the installation of this styrofoam from the if you look at it face on, you see it like it's like this, then there'd be a big gap, and it's like this, then they bodged a piece on like this, and there's another piece on like this, and then there's some like this. What happens is all these holes, they negate the effect of the installation. Negate does not mean diminish it. They don't reduce the effect of the insulation. They reduce it to effectively zero. So it's effectively become an uninsulated house. If you have the material and it's poorly installed, it's improperly installed, you might as well not have bothered doing it at all. And if you didn't bother doing it at all, then your control layers are not working to keep your house properly warm, and the homeowners are not going to be happy. And these say a house someone's paid these days, they paid $1 million. I don't know how much they paid, but let's just say $1 million for the house. It's a conceivable round number. So you paid $1 million for a house, and you're cold. You're cold inside your house. You run your furnace, and remember I said the furnaces are kind of a symptom of not good, but you run your furnace and it runs all the time, and still your house is cold. Well, it's not as simple as saying it's because the furnace is too small. It's your house being cold is a symptom. It's a manifestation. I'm going to come closer for this. I'm going to say a cold house is a manifestation of scores or dozens or many, many, many reasons. And in a modern era, it's inexcusable. And if you're a developer and you're going to build 100 dwellings, you're going to build 200 dwellings, you're going to build 10 dwellings, and then you're going to hire a general contractor and an architecture firm to do this. And the architecture firm is going to hire a mechanical engineering firm to create the design and the drawings, and a whole bunch of stuff is going to happen. And then and in the construction process, there's control layers too. There's starting at the back. There's the homeowner is going to do an inspection, but they're not doing an inspection till it's too late. The authority, the municipal authority or the government agency, is going to have an inspector that hopefully is going to come, and they're going to inspect. But how good they're going to do. The general contractor has to make sure that the sub-trade, their site supervision, the sub-trades are doing their job properly. The sub-trade supervisor has to make sure that the specific people that are doing the work are doing it in accordance with the manufacturer's instructions, in accordance with the design drawings, in accordance with the proper way that it's supposed to be. Now, this is kind of I'm saying this stuff out loud, and I think that most people should say, well, that's completely obvious. That has to happen. Well, for some reason, it varies widely by the region that you live, really. In some regions, the quality of the construction is better than other regions. But that's not good. It has to be good. The quality of construction has to be excellent. Well, not excellent. The quality of construction has to meet the legal requirements. The materials that are applied have to be applied in accordance with the manufacturer's instructions. The places have to be built in accordance with the design. The design has to be designed in accordance with the climate conditions and the rules that apply. And that's it. Now, if you follow, I might have another video I talked about construction disputes, or I've been in some large projects, and I've been dispatched to gather up more money from a very large project. You're going to have someone called the contracts administrator. So the contracts administrator is usually the only person that actually reads the contract, although I read contracts exactly. And so I get sent to them to get more money, and we were having our discussion in a kind of a friendly way. And he says, well, it's not like we wanted you to do a bad job. We hired you to do a good job, and yeah, it's going to cost, so we'll pay you. That's it. It's going to cost, we'll pay you. you know. But anyway, this is related to personal economics. It's related to public policy. It's related to life. It's related to everything. And this idea that we have to be building houses. And when I say houses, I really mean dwellings. I mean, single-family detached houses are, you know, if you ask someone that's home, you know, that's trying to find a place to live and have their children, they don't necessarily want to have everyone maybe would like to have a single detached house, but if you say, you know what, if you had a comfortable 1,000 square foot apartment with 3 bedrooms and a beautiful bathroom and a gorgeous kitchen, and by gorgeous I mean like good, in a good area where everyone's cooperative, most people take that in a heartbeat. I know I will, for sure. Anyway, my name's Bruce. This is my channel. Thank you for everything. Thank you for watching. It boggles my mind that people watch at all. Really, it does. And my motivation here is to try to express some ideas that I have that I think are important. And if you agree with me or if you disagree with me, please leave a comment, subscribe. That's it. This one, hey, this is like, I've been going for a while. Okay, thank you. Bye.